Okay, now we are on tutorial 1, question 3. In tutorial 1, question 3, you are given two vectors A and B, right? Two vectors A and B. In part A of the question, you are asked to find the length of projection of A onto B. If this is a vector A and this is a vector B, where is that length of projection of A onto B? Remember in the earlier video, I showed you something like this, no? Right? So this is so-called the length of projection of A onto B. Right? Let me draw that. Okay. This is actually the length of projection of A onto B. If you could recall, in the video on projection, I've told you, or you've learned that to find this length is simply A dot B hat. Okay? To find this length is A dot B hat. So what I'm going to do right now is to find the length. It is equals to modulus of A dot B. To get B hat, right, I divide by the modulus of B, which is 7 square minus 14 square and then 14 square. Right. This is how you can find so-called the length of projection of A onto B. If you're dealing with big numbers, right, you can actually make your arithmetic nicer by doing this. You can take out 9, you can take out 7. 9 and 7 taken out is 63. Then you're left with 1, 1, 1, dot with 1 minus 2, 2. And for the denominator, right, for the denominator, you can actually choose to take out 7 square, which therefore is just 7. And then just give you 1 square minus 2 square, 2 square. So you can make your arithmetic actually slightly nicer. Right, so for the numerator, I have 63 here, right? This is 7 and this will give you 3. So 63 divided by 7 and divided by 3 will give you 3. And then the dot product is 1 and then just 1. So answer is just 3. So this is the length of projection of A onto B. Okay. In part B of the question, you're asked to find the resolution of the vector A in two directions. You want to resolve A into two components. One of them is parallel to B. So you're asking for this vector. Let's call this vector C. And then they're asking for this vector D. Let's call this vector D. I can draw my vector D over here, like this. It's the same, it's the same, alright, it's the same. So C and D are so-called the resolution of the vector A in two directions. One vector is along the B, and the other vector is perpendicular to B, sorry. Right? So once again, to resolve these vectors A into a vector here, which is C, and a vector there, which is D. It's the same as this vector, right? Same. Right. In my earlier video, I've shown you that to find the vector C is equals to this rounded bracket A dot B hat. Okay. I can borrow the calculation of A dot B cat from here, no? So if you look carefully, I can borrow from this calculation. A dot B cat, right? You'll find that it's actually 3. And then B cat is equals to the vector B divided by its modulus. The vector B, okay, maybe I write like this. Again, maybe I write this, easier to write. A dot B cap is 3 and then B cap is equals to vector B vector B, which is 7 minus 14 over the magnitude of B. What is the magnitude of B? The magnitude of B, if you do your calculation, you get 21. You can just square, add it together, and then square it. It'll be 21. Okay, let me double check on my calculator, because we have earlier on calculated the same thing, you know. Okay, and then this one will give you 3 over, okay, let me make it faster. This will give you 1 minus 2 and 2. Right, this is the vector C. Now to find the vector D, right? To find the vector D, this vector D is found by taking the vector A minus C. The vector A, right? The vector A minus C. 9 minus 1 is 8. And then 9 minus 2 is 11. Then 7. This is how I get the two vectors. What are two vectors? The vector C and the vector D. And these two vectors are also called the components of the vector A in direction B and perpendicular to B. And this is how you actually achieve question 3 of tutorial 1.